So tonight we are going to be taking kind of a step back for this first part of our lesson tonight from React. And I want to talk about JavaScript in general. And I even want to go beyond JavaScript in general. And I want to talk about computer programming and these ideas and concepts that you're going to see throughout your career as a programmer, whether you stick with web development or you do anything else. These are concepts that are going to stick with us. And then we're going to move into something called the reducer pattern. And that's kind of a React-ish thing, but we're going to do it without React at first, and then we're gonna introduce it in React. And this is really a setup for a cool hook that's in React, also the Redux library that we'll be learning about next year. So this is some cool core foundational stuff that you want to always have in the back of your mind and thinking about it, and especially as you work with data and manipulate data and have it appear on your page. You want to have these concepts in your mind. So let me share my screen and we will get started. If I can find the screen I want to share. I think that's it. Cool, there we are. So I just want to kind of go over what we're going to be talking about tonight. A couple of things. First and foremost, we're going to be talking about what immutability is. If you've never heard this term, welcome. It is a term you'll hear quite a bit from now on, but what it is and how it works in programming in general, and demonstrate its benefits as a whole. So that's really, we're not even going to touch a line of React until we get to like the third one here. Then we're going to describe what a reducer function is. And this is kind of a concept that's not necessarily at this moment, not necessarily a set in stone way of doing things, but we're just going to talk about it as a concept. And then we're going to jump into some React and use this cool hook called useReducer. And it's going to allow us to manage state in our app, and allow us to manipulate the state in a specific way. I'll just leave it at that. But you've all done your TK prep time, so you all know what I'm talking about. First and foremost, let's jump into some plain old JavaScript code. Let me share this with you. And we'll get started. So the first thing I want to talk about are our primitives. So who can tell me what a primitive is in JavaScript? String is a primitive, right? Let's just put it on the same line. Boolean. And one more is, ooh, no one's gotten it yet. Undefined and null, I think undefined and null are considered primitives. So Jackie, integer, but in JavaScript, we don't differentiate between integers and floats, right? We just call it a number. Okay. If you're in another language, you're going to differentiate between an integer and a float and a big int and small int and all kinds of cool stuff. In JavaScript, it's all just numbers. So yeah, these are our main three primitives. There are others, undefined and null. I'm assuming, yes, those are primitives as well. Symbol, it might be. But these are the three we think of in JavaScript when we think of primitives, okay? String, Boolean, and number. So let's create one. This is going back to our pre-course days. I'm going to use the let keyword. It's important for this demonstration, not necessarily important in the long run, but I'm just going to say name. And I'll put my name down. Very, very unimaginative, but there we go. So I'm going to say let name equals Dan. So when I do this and I run this code, you're not going to see anything on the screen. What's happening? Who can kind of, on a very high level, tell me what's happening when I run this code. And if you don't know, that's totally fine. Dylan will be getting to objects and arrays. Yes. So Dylan and Tim both, and there's more typing. Perfect. What happens is we're creating a string and we are putting that string in memory. Okay. Before we do anything, we're creating a string, we're putting that string in memory, and then, of course, Replit wants to be weird. Then we're going to create a variable and assign that variable to that place in memory. That's what's happening here, okay? We can tell that because we see the open and close quotes. We know we're creating a brand new string. And then when we see this single equals, we know that's an assignment operator, and we are assigning a variable. And let's not, I mean, we can think about it right now when we're using primitives, that we're assigning it to this value, okay? And that value is going to be stored in memory. All right, so the same can be said for any primitives. We are creating a number, storing it in memory, and assigning a variable to that value. And Boolean might actually already have it. We have a value that's false, and we are storing. We are assigning the bool to false. So what we're saying here is that we are assigning our variables to a value, okay? And the thing is that these values are what we call immutable, all right? Immutable, okay, hopefully that's right. I'm a programmer, I'm not an English major. Okay, so these are immutable. That means we can never change that value. What we can do is we can reassign it, right? Plus, okay, we can reassign it. So we're reassigning name to a new value. That works. All right, there we go. But if I just do something like this, we're never going to change that original value, okay? We can't. Immutable means that it is untouchable. We cannot change it forever. We can manipulate what the variable is assigned to, right? But we can't change that initial value. It is immutable. You can try. You can think of 100,000 different ways to do it. It's just not possible in JavaScript. And I had a little presentation. Let's go here. Let's go. Oh no, I don't want to ruin your. Let's go like a little one of these. So we can kind of see here that we have a name one is to Dan. What JavaScript is going to do is it's going to create this, and it is going to put it into memory, and it's going to give us a unique address in our memory. Okay, so it's going to be string something 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 address. All right. Then what happens when we create another variable, and let's say we point it back to that original? What that's going to do is that's awfully off right there. What that's going to do is it's going to say like, oh yeah, name two is assigned to whatever name one is, right? So it's going to say name one, and it's going to tell us name one is assigned to this place in memory. And so when we change name one, name two, it's going to create a new string. Name two is still assigned to that place in memory. Okay. Spoilers for sure. And that's what it is. Okay. So let's go through this and let's check this out. So let's go name, and let's go let name two equal first name I see, Joshua. Okay. Oop, no. Why did I do that? Sorry. We'll get there in a minute. We say name, all right? So I'm going to go up here in console log name2. And we should see Dan, right? We'll go, this is name2. All right. And we'll see, this is name2, Dan, okay? So then if I say name equals Joshua, what do we expect name2 to be? What do we expect to see console log to the screen? We kind of gave it away in the last thing, right? Yeah, because name2 is still pointing at the value that we created here, okay? So we're gonna run it and we'll still see name2 is Dan, but name, and we can, let's just do a little, oh, that was the wrong shortcut. We can now see that name is Joshua, right? And name2 is still Dan. Okay, so what this is telling us is that name2 is not necessarily pointing at name, it's pointing at the value that name is, and that value is that string of Dan. So it's pointing at that place in memory now. And when we change what name is, we're pointing it at a new string, a new place in memory. No, name2 is still the same reference in memory to Dan, okay? So let's just, and we can take as much time on this as we need, because this is important stuff. So name2, remember, coming back to our little presentation here, name2, no matter what name1 originally was pointing to, name2 is going to point to that place in memory, that original place. When we reassign name1, it's going to point to a new place in memory. Okay, but that original place in memory still exists, all right? Just redundant as in how, Jackie? I'd love a little bit of clarification on that. All we're really saying here is that we are pointing to the value, the place in memory. Even when we assign a variable to another variable, it's just going to say name2 equals name1 equals Dan at that exact moment, right? And we're going to point it to whatever value in memory that we are pointing to. Any questions on this? And this goes for all primitives. Okay, great question. So Jackie said, meaning if it's not creating a new instance, it's just redundant to say name2. Why would we ever need to do that when name is already assigned? Well, we're reassigning name, right? Maybe we wanted to capture what name originally was, knowing we were going to reassign it later, right? So this goes into some algorithm stuff in the future where you need to maybe have a temporary variable pointing to something and then change that something later, but still have access to what it originally was. Okay, and there's a lot of different reasons for this, but what we're saying is name2 is equal to whatever name1 was, and then we're going to eventually change what name1 is. This is intentional. It is right, actually. What's not right is what's going to come next. What's not going to seem right at first is what's going to come next. Great question from Kristen. Not understanding why it would not create an error since there are two with the same name. So we're creating these and we're using let here so that we can reassign it, but we're not creating more than one variable with the same name here. Dylan, we're not going to get into the concept of pointers, but you can think of it like that. Yep. Okay, so this is how primitives work, and this is how, and honestly, at the end of this, we're going to see something And it's how essentially everything works in JavaScript too. But just know that primitives are immutable. That no matter what, I can't change what this string is. Once I set a place in memory for this string, if I do anything, what it's going to do is it's going to create a new string and a new place in memory, and it's going to reassign it to that new place in memory. Okay. Even if I did that, right? It's still going to create a new string, new place in memory, and point it to that new place in memory. All right. Any other questions right now regarding this? I see some typing, so I'm gonna. Okay. I'm gonna move on. Now, let's talk about objects and arrays. Objects and arrays are objects and arrays. We know that, right? Objects and arrays are mutable, right? So let's see, what am I talking about? Let's go let class R equal, I'm gonna do Dan, I'm gonna do the first two I see, drag, and Dylan. Okay. So what if I say class R dot push I'm going to console log class R. I'm going to just go ahead and get rid of those. Run it. And we're going to see that Jackie has been added to our array. By using dot push, are we creating a brand new place in memory for this array? Question. We are not, okay? What we are doing is we are creating a new place in memory for this string, but this array is the same place in memory that it was here, as it is here, as it is here, okay? And this is called assigning by reference. And so I want to actually go into our object now. So when we do something like push, or we say class R, 1, 2, 3, 4 equals Joshua, we are creating a new value for the string, but we are using the same array. Okay, this means arrays are mutable. They are changeable. We can mutate them. Okay, and that is totally fine. That's a feature of JavaScript. That's why I can do this. If you didn't know you could do this, you can do this, and you're not going to get an error because we are not changing the value of what class R is pointing to. Okay, but for right now, we're going to keep it at let. All right, so object or arrays are mutable. Let's see. Okay, cool. And let's go objects. Object equals, let's do an object. Let's do a car. We're going to go make Ford model expedition. I don't even know if they make Ford expeditions anymore. Cool. So we have an object. We can see before our mutation, we have our object here, make Ford model expedition. we're going to say object dot make equals Toyota. Mutation, same object. All right. And we actually have the same exact object here. Okay. But we are mutating it. All right. We are assigning a key to something else. Right. But we are not not changing the reference to what object is. Okay. We're not going to touch on functions today, but we will. Let's see. Okay. Now we're gonna play a fun game. This is where things get wacky until you understand it. Let's create an object 2. And let's point it to object 1. Okay. And let's, instead of saying, let's go object 2. Let's do object 1. Okay, so we should expect to see, because I didn't say object 1. There we go. All right. Thank you for my errors. Still getting errors. Object. Why am I getting an error? That's why. Okay. Great. Oh, I don't want to change that. Okay. Now we're on the right pace here. All right, we have the same object. And in fact, let's do something like this. Triple equals object 1. Do you think we're going to see true or false for object 2 triple equals object 1? False, false, false. False, false, false. We're actually going to get true. Okay, this is funky. You're probably like, well, no objects are supposed to equal each other. But what we're doing here is object 1 equals this place in memory. Object 2 also equals that place in memory. So we're going to get true. All right, let's make things a little bit trickier. Okay, so I'm going to say after you mutation object 1, and what are we going to expect object 1 to be? We're going to expect object 1 to be make Toyota, right? Model expedition. That's fine. What are we going to expect object 2 to be? What make are we going to expect object 2 to be? Ooh, looks like we're currently at 1, 2, 3, 4, 5 Fords, 3 Toyotas, 4 Toyotas. We're about 50-50 here. Let's run it and find out. Look at that. After mutation, object 1 is make Toyota, of course, because we changed object 1. And after mutation object 2, we have make Toyota. What's even going on here, right? What's happening is we are pointing to a reference to an object in memory. This whole object is a place in memory, okay? So let's come through our little presentation here. And let's come to our reference types, which are objects and arrays. All right. So when I create object 1 and I have a key value pair of Dan, First and foremost, let me ask you this question. This is an important distinction to make and an important clue to clue you into what's happening. How do I know a new object is being created in memory? Does anyone know? Just by this one line of code here, how do I know a new object is being created in memory? Yeah, it's actually the curly brackets, the curly boys. Yes. Yes, this is called an object literal. When you see curly brackets and they are referring to an object, a brand new object is created in memory. Keep that in your head because we're going to revisit that later. Okay. This means a brand new object is created in memory, and when we see those curly brackets. So, memory, object. There we go. We got an object in our memory now that has a key value pair of name. We know that a brand new string was created in memory because we see our string quotes on here, right? But we're just worried about the object right now. Okay. So then we say object one, no matter what, is referencing this place in memory, period. Okay. Now we have object two, and we're going to point it to object one. And what we're doing here, remember, is we are pointing it to whatever object one is pointed to, which in this case is this place in memory. All right, let's keep that in mind there, that both of these are pointed to the same exact place in memory. All right, oh, what just happened there? Okay, I don't know why that did that, but say now we create a, we take object, we just say object one. So what we're really saying is this place in memory dot name is equal to Josh. Okay, that means that this place in memory we have changed. We have mutated this place in memory to say that the name is equal to Josh. Since both of these are pointing to the same place in memory, they're both going to reflect that change. All right. Pretty wild to think about. Let's go walk through it a little bit more. Okay. So if I say object2.make equals Honda, what are we going to expect the make to be on both object one and object two here? Are we gonna, is object one gonna say Toyota and object two gonna say Honda? Are they both gonna say Toyota? Are they both gonna say Honda? Right? Object one is pointing to the original definition of that object. We've got, most are saying both Honda. We have a both. We have a Toyota and Honda. So just like before, remember, those are both pointing to the same exact place in memory. So when I mutate it, when I say object two, what I'm really saying is object this address dot name or dot make. And I'm not only changing what object two is or object one is, I'm changing that place in memory. I'm mutating that place in memory. Hondan. So this is a little tricky, and we got to start thinking about this, about reference and what we're doing and mutability. So we can actually mutate an object, right? Are there any questions right now on this? I know it might be a little like, what is even happening here? Why is it doing this? Hopefully that really amazing professional looking slide that I created works to explain things. Why did it change object one? It didn't change object one. So let me just reinstate that. We're not changing what object one is, and we're not changing what object two is. What we're changing is the place in memory that both of those variables are assigned to. Okay. It changed this. This is what it changed. It didn't change this, and it didn't change this. It only changed this. And since these are both assigned to that place in memory, those are both going to reflect that. Does that make sense? Let's see. Whenever an object is created, it is stored in memory. Yes. When you reference that object one in another object, the second object is also referring to that place in memory. Yes. When you change one, so let me try to get you to think about it in a different aspect. I'm not changing anything about these variables. I'm changing something about what's stored in memory here. Okay. So all I'm saying is this object one is pointed to this place in memory. This object two is pointed to this place in memory. When I use, syntax like this, object one, JavaScript is going to say, oh, cool. What is object one pointing to? It's going to be like, oh, it's this place in memory called an object. Whatever the key of name is. If there is not one, we'll create it. If there is, we'll change it to Josh, and we're actually changing that place in memory. So now when we look at what object two is, that place in memory has changed, and that's still what it is. I am not changing reference at all. I am changing the property of the, and maybe these variable names are off. Let's see. Is something fundamental to computer science or something you bring up in JavaScript every TD change languages? Nope, this is computer science. All right, you can look up reference types. Jackie, there is. And we are gonna discover what that is after our break. But I wanna make sure this is as clear as possible before we go to break, and then we can come back and find out how to create how to create a copy of that first one. It's not the reducer pattern yet. Actually, no, it's not. This is all leading up to the reducer pattern. This is stuff you have to understand. Maybe not fully understand, but like understand before we get to reducers. So does anyone have any issues with me saying, when I say this, I am not changing what object one is fundamentally. I am changing what object one is referencing, okay? And it is referencing this object. I hate the term that I used, obj1. The first variable, I am not changing what the first variable is. I am changing what it is referencing. The second variable is also referencing that same exact place in memory. Do arrays mutate in the same way as these objects? They do. 100%. And let me blow your mind a little bit more. Arrays are just objects. Arrays are just objects with number keys. That's it. But don't worry about that right now. Warren. I'm not going to go there, but yes. Functions are objects as well. Everything is an object in JavaScript, right? But yes, but the arrays actually being objects with number keys, that's something that a lot of people don't quite realize. Okay. Any issues with what's going on here? This is important. So I want to make sure that we understand what's actually happening here. See some typing. Jose, yes, 100%. We are not changing what object one is. What we are changing is a key value pair inside of this place in memory. Yes. Yes, correct. So when I say object2.name, I'm still changing this same place in memory, and both of these variables are pointing to the same place in memory, right? Until they're not. And we can do that too, and we'll see. All right, I want to take a break because I want to get down to the nitty gritty of things and why we're really learning this stuff. So let's doop, doop, 5-minute timer. And I'll see you in 5. If you have any further questions, like always, post them in Slack and I'll get to them when we're done with the break. See ya. All right, come on back. I think that that's probably like the most mind-blowing part of tonight's lesson. Although we are going to talk about once you get that concept down, that we're really just assigning our variables to places in memory, which that Zen quote was so perfect. Thank you, Jules, for that. Yeah, like that's exactly what it is. Imagine if you personally and me were both pointing at the moon, right? And I changed something on the moon. You're still pointing at the moon. I'm still pointing at the moon, right? And that's what we're doing with our variables here. What you're going to see is the same as what I'm going to see, right? We're still pointing at the same exact place. And that's what happens when we mutate an object or an array. And we have two objects or two variables pointing to the same place in memory. Okay, so let's come back into it. All right. I'm gonna get rid of that. I want to point out one more thing. Let's go back to cars. Car 1 equals model. Let's go make Tesla. We're just going to go with our first one and only, right? And then let's do this. Car 2 equals Tesla. And let's say car 1 dot make equals car make Kia. All right. 1 second. Choice. Okay. What is going to print on my screen when I run right now? Oh, sorry, the make. Is it going to be Tesla or is it going to be Kia? I only want you to look at lines 46 down, okay? Just those lines right there. Nothing else matters before this. Tesla or Kia? Please answer in the poll. Ooh, we're about 60-40 right now, almost 50-50. Okay, let's walk through this and see what's happening here. All right. We have created a variable. We are assigning it to this object. What do we know when we see the object literal or curly braces defining an object? What do we know is happening then? We're creating a brand new object, which is creating a brand new place in memory. And we are assigning car 1 to it. Okay? So this is, let's just say object, some random place in memory. Okay, that's what it is. Now, the next line, we see that we are creating curly braces, right? What do we know when we see curly braces or an object literal is happening? I hope you just like up arrowed and entered Antonio. We are creating a brand new object and a brand new place in memory, right? Object, and this one's going to be a different address for a memory, okay? Are these the same objects? Object 1 and object 2? They're not, right? They are two very different places in memory. They look identical. They have identical keys and values, but they're not the same object. So when we change the one, car one, we're actually changing this object's make to Kia. We're not affecting car two at all. Oh, that's what I want to get rid of. Let's run that again. And we'll see that car two is the same. Also, what do you think is going to console log now? Are we going to get true or false? That car two is triple equal to car one. This is a false, right? These are two different objects. Okay, so that's why you'll always see, like, you're like, how is that false? You know, they have the same key, they have the same value, they don't have any extra stuff. It's going to be false every single time. But if I did this, would it be true or false? Now it would be true, right? Because we're pointing to the same place in memory. Okay. Are there any questions on this right now? I hope there are some light bulbs going off. If you don't have your light bulb going off yet, that's totally fine, but we'll get there. Okay. All right. We're going to stick with our car stuff. So we're going to go truck. Truck one. So let's say we had an object, and let's say we wanted to assign, just like we did up here, name two to name, right? Let's say we wanted to assign it to that original object. What would we need to do to make sure that if we let's take, actually we're going to take a step back. What do we have to do? What do we have to assign truck two to make sure that when we change truck one, truck two won't change? What do we have to assign it to? Period. If we change truck one, we do not want truck two to change. So Jackie, if we assign it equal to truck one and we change truck one, it will change what truck two says it is. What we need to do is we need to create a brand new object, right? We know that when we create a brand new object, that it doesn't change the second one, right? But we want to make sure that it has all the same stuff, okay, no matter what, right? So what we can do is we can use something called object.assign, okay? There's going to be much easier ways of doing this. Object.assign, I thought I had, nope, I thought I had my MDN up here. Object.assign is going to take an object, we're going to give it an empty object, and then it is going to make what we call a shallow copy. We'll talk about shallow copy versus deep copy later on. It is going to take all of the key value pairs of this object, put them into a brand new object. Notice we see that we have curly brackets here. That means we're creating a brand new object. We're assigning this brand new object all the keys and values in this object. Okay? So then when we say truck one equals truck two, we're going to get a false. All right? But when we console log them, they're going to look identical. Look at that. Okay, so let's take a step back and understand what's happening here. Truck one, we're assigning it to a new object. This is a new place in memory. Truck two, we are using a special method on the object class called assign. And what that's going to do is that's going to, and I can, well, I'm not going to go there right now. It's going to take an object, and in this case, we're going to give it a brand new place in memory. So it is creating a brand new place in memory, and it is assigning all of the key value pairs of truck1 to that new object. We'll get to the spread operator, don't worry. You got to understand, see, the whole thing is you have to understand your history first, because you're going to see object.assign in the wild. Okay, and I just want you to understand what it is. No. Object.create is for prototype, and we don't really want to mess with that right now. Okay, so we're going to do object.assign. This is what you're going to see a lot in reducers. And so just know what this is doing. What we're doing here is we're creating a brand new object, and we can tell because we see that brand new object, right? We can also we're going to create a brand new object, use ES8, I think, ES7 or 8 syntax, and we can spread our old object. Okay, these are the same exact thing that's happening here. This is just a little bit easier to write. Okay, so what the spread operator does, remember, is it takes all of the key value pairs of this object and it puts them in this brand new object. Okay, so we'll see nothing has changed, right? But yet they're not the same object. Yes, we have to know where we've been to understand where we're going. Are there any questions about this? So what we're doing is we're creating a copy of this original object here. And remember, we know our rule of thumb is when we see curly braces that are related to an object, that means a new object is being created. We could also say the same about an array, that a new array is being created. It is a shallow copy, yes. And we'll get into that shallow copy, deep copy stuff a little bit later. Why would we want to do this? Well, just like before, we wanted to create a copy of what the original, we wanted to maintain, to not mutate our original object, okay? So now we can say this. Now we can go truck2 dot make equals Dodge. And we're not going to change what truck1 was, right? Yeah, so let me ask you this question for you all. Where have we seen already immutability in our code? Where have we already seen it? Recently. The idea that we don't want to change the original object. I'm going to say state, right? What happens if I have some code and I say a class component and I say name Dan? Oh. Do I say this dot state dot name equals Dan to change it? No, I don't, right? I use set state. Not only that, but I create a brand new object. Look at that. I'm creating a brand new object, and I'm only changing the piece of state I want to change in that new object. Okay? So we have seen that already, right? If I was using hooks, okay? I'll just say state. No, I'm going to say truck set truck equals use state. And I'll say Ford. Let's go make Ford. I don't say truck dot make equals Chevy, right? I say set truck to a new object with the key value pairs. Okay, so we have already been using this idea of immutability, right? If I were to do set state and I said this dot state dot name equals Dan, that wouldn't work either, right? So we have already used this concept of immutability. Ah, Jules, yes, it does mean that. So it gives us the, I don't want to go there yet. But yes, default state will always remain in memory. All of your states will remain in memory. Yes. So we've already been using immutability in our objects. Okay. We do it in arrays as well. So we've seen two different ways of creating a new object. What are some ways we can use to create a new array? What? Trucks. What's some way we can create a new array? So remember, dot push isn't going to create a new array. It is going to simply push that new value onto the old array. Okay. So we can do just like our object, the spread operator works for arrays as well. We can do, there's a bunch for arrays. We can use the slice method and give it the starting of 0, and that's going to create a brand new array with all of the same stuff in there for us. This is what you will see as far as legacy goes, just like our object assign, and this is what you will see as far as modern new stuff goes, and modern meaning this year. We can also do trucks. Can I spell trucks? Trucks. Oh my gosh. You know when you spell something 1,000 times and it starts to look wrong? We can also do something like map. Map is going to give us a new array every single time, right? And that'll just give us a brand new array with all the same items in it. And we're going to be using map a lot. We have used map a lot. Map gives us a brand new array. None of these arrays are of the same reference. They're not the same place in memory, right? We can also do dot filter, dot reduce, and there's some others we can use as well. Okay, so that's how we create new arrays. That's how we create new objects. And we are creating these with the idea that we want to create a brand new place in memory for these things. This is immutability, okay? We don't want to mutate the original item. Okay, and that's not always the case, but that's going to be the case for the most part in React. And coming up to it today we're going to use reducer, and after the break we'll use redux. All right. So, any questions on this stuff right now? Because we're going to jump into our reducer. Jules, I would say that yes, most languages take up so much space in memory, and I would say that most languages take up more space in memory than JavaScript does. Space doesn't mean it's not faster, but yeah. You've got a lot of JavaScript is actually pretty simple when it comes to this stuff. Yeah, garbage collection. We have garbage collection in JavaScript as well. We just don't have to worry about it too much. Where you have to manually garbage collect in other languages. All right, we're going to move on. To our reducer pattern. All right, this is a pattern, okay? This is simply a pattern. This is not, and when we get to Redux, well, when we get to Redux, this is going to be required. When we use reducer, this is going to be required. But all of this stuff, all JavaScript. This is all JavaScript. We haven't talked about React or Redux or anything since then. This is going to be React, okay? So let's go with let current car. We're going to create a new car. And I want to make sure we're down here. We're not worried about that stuff. Can you create a new car? And we're going to say make Chevrolet model Corvette. And let's do a year. 2010. Okay, we got a 9-year-old Chevy Corvette. All right. So imagine that this is our state. Okay, this is our state. And this is our current, and let's call it not current car. Let's call it state. And let's not call it our current state. Let's call it our initial state. Okay. I'm not going to get in an argument about what cars are cooler or better or anything. It gets you from point A to point B. But let's just say that this is our initial state here. All right. So if we were in, using hooks, we would say const. We could just say state, set state, use state, and we can just say initial state. We're doing this outside of the context of React right this second, okay? What we're going to do is we're going to create what's called a reducer. And what a reducer is going to do is it is going to take our state. It is going to take what's called an action, and it is going to reduce things down to a new state, okay? So I'm going to say we're going to give it a state parameter and what we call an action parameter. And what we want to do is we want to return a new state. So in this case, let's just return state, just in general, all right? And we'll go console.log, and we'll say initial state, and we'll say reducer initial state. Dip, dip, dip. Oh yeah, gotta get rid of all that stuff. All of that fun stuff. There we go. We don't have any more console logs, right? Now we do. Oh, there they are. Okay. So what we see here is that we have our initial state and our state returned from the reducer. Are these identical places in memory? Question for you all. Are they the same place in memory? Got a couple no's, a couple yeses. So let's look at what's happening. We have this initial state. We're creating a new object. Are we creating another new object anywhere in these 8 lines of code? We're not, right? We're just passing in this object or the reference to this object, and then returning that. So these are actually going to be the same exact place in code, in our memory. Okay. So we are not mutating our state, of course, thanks. We're not mutating our state, but we're not doing anything to it, right? We're just returning it what it is, okay? So this is our reducer. Let's create an action, our first action. What an action is it's going to be another object. And when we say reducer, what we mean is that we're going to take two objects, we're going to do some stuff in here, and then we're going to return a new object or a new state, okay? So let's make this new action. Every single action in the future for us is going to need a type, which is going to be a string, and it's going to need a payload of some sort. It doesn't need a payload. This is optional, okay? So I'm going to just put optional, but it needs a type. In this case, let's make our type of change year. And let's make our payload 2020. All right. So what we have here is we have an initial state, which is an object, and we have an action, which is an object. Yeah, if I did return of state like that, would this be false or true? I was kind of leading with that. It is going to be false, right? Because we are now creating a new object. And we're going to see that in just a moment. But we always kind of want to start our reducer with returning the original state. And we'll see why in a moment. Okay. So let's do, I'm going to get rid of this console log for a second. Let's do something now in our reducer. So we want to pass in, let's go let new state equal reducer initial state and first action. Okay. What we want to do in our reducer here is we want to say, what is our action here? Let's talk through this real quick. What's our action? What is it at this point? When I call it and I pass this in, our action is an object, right? That's our action right now. It is an object. We can, when we write a reducer, we can, like I said, we always need a type. We can always assume that our action is two things, going to be an object and going to have a type, okay? A type key on it, okay? We can always assume those two things. So let's say if action.type equals change year. I want to change the year on that state. Else, let's just return that old state. So if I want to change the year, but I do not want to change, I do not want to mutate that initial state, how can I do this? Create a new object, right? What are the two ways I can create a new object in JavaScript? There are more than two ways, but what are the two ways we know of right now? We can use object.assign, or we can use the spread operator. Which do you prefer? Everyone prefers spread. So we are going to return a new instance, a new object, a new place in memory. We are going to spread our original state. Okay, so that's going to take everything in our original state or whatever was passed into that state, and it's going to create a new or create a shallow copy of it all. And then if I put a comma and I add another key value pair, if it comes after that initial state, it's going to override it if it's there, okay? So I can say year, and I can say action.payload. Okay? All right. Is initial state going to be changed? Payload is a number here, 2020. It can be a string. Payload can be anything. It can be an object. It could be an array. It could be anything you want. You'll just have to know that when you create your own reducer, what payload is going to be. So is initial state going to be changed? It is not, right? I see a few no's on there. I see a yes, but it's not going to be changed, right? Because I've passed in the initial state, which is our state here. I've passed in this action, which is our object here. And I said, if the action type is change year, then we're going to return a new copy of the state with that new year in there. If it is not, then we're just going to return our initial state and not do anything to it. Okay. So we can see our initial state here is still the same. It still exists in memory. It still has the year 2010. Our new state is here, and it has the year 2020. Okay. What if I did this? What is new state going to equal? I don't see any typing, so I'm going to run it. It's going to be the same. It's going to be the exact same thing. Right? It's going to be that initial state again, because that didn't exactly equal to change year. So we need to make sure that our type is the same throughout. Okay. You all might be like, what is this crazy thing? This is our reducer pattern here. You are going to become very familiar with the reducer pattern. Okay. So let's do another action. And let's go, we're just going to call this action change model. We're going to say type, change model. And we'll say payload on this is going to be, what's a Chevy model? Oh my gosh, I can't think of any Chevys right now. Corvette, Chevy make cars Blazer. Let's go with Blazer. I don't even know if they still make the Blazer, but all right. So now let's say we call that reducer again with whatever our new state was, right? We know what our new state is. And let's go in here, change year. It should be the same. Let me just run that again. We can see it on the screen. Our new state is, let's go, of course. Our new state has the year 2020. Now let's say we run this with our new state in there, okay? What are we going to get out for newer state? We're going with Chevys, Joshua, sorry. What are we going to get out of newer state? We're going to get that original new state object back, right? Because we don't have an if action type equals change model. So it's just going to return that original state to us. And that's not the original, the initial state. That's the state we passed into it, okay? So we can see new state equals newer state. We should get a true for that one. Because yeah, it's just giving us back the same old state that we gave it, right? But let's add some logic in here. Else if action.type equals change model. Then what we're going to want to do is we want to return what do we want to return there if the action type is change model? We want to, number one, create a brand new object. We do not want to mutate our original object, right? So we're going to create a brand new object. We want to spread the state out, and we want to change our model to action.payload. Okay. Does everybody understand why we're doing these returns in here? Are there any questions on this right now? We do not ever want to say state dot model equals something. We don't want to say, oh, we're going to go switch statements. Don't worry about that. We got to build up to it. We never, ever want to mutate our state. Never mutate state. Okay, ever. That goes for React. We never want to mutate our state. That goes for the reducer pattern here. We never want to mutate state. If we want to change something on here, we want to return a brand new object. Okay. Or we're going to return the same object with nothing mutated. React's not pretty. They're very against mutations. Mutations lead to issues. And we'll see that we can get some cool stuff out of not mutating. All right. So now let's run it. And we're now going to see our initial is our initial state. Our new is the newer state. And then our latest, we have, oh, where did I go wrong? Oh, yeah, there we go. Newer state. Okay, I didn't go wrong. I just didn't console log the right thing. Now our latest has our latest state in there. But notice that all of our original states still exist in memory, right? All of our original states exist in memory. All right, one more thing before we go to break, and then we actually throw this into React, is, as Joshua mentioned, our if statements here. When we have two, that's fine. But a lot of times in a reducer, we could have dozens. And if we say if, else 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 if, it works. But we have a more succinct pattern that we can use. And it's called the switch statement. So if you're not familiar with switch statements, you will be soon, and you will be very comfortable using them. But we're going to essentially take this if, and I'm going to actually do that. And what we're going to say is we're going to say switch, and then we give it the item we want it to switch on. So in this case, what is the item that we are constantly checking in our if statements? What is it? Yeah, the type, or more specifically, the action.type, right? We're not ever saying action.payload equals something. We're always saying action.type. So we can just say action.type. So we are going to switch on the action.type. And thanks for Dylan for putting the MDN switch in there. the documentation for it, because you will be referencing that, because I always reference it, because I'm like, is there parentheses around the case statement? It's just, you'll get used to it though. And then instead of saying if, else if, we're going to say case. And we say case, and let's say change year, and then we give it a colon. Okay, so this is saying if action type is change year, then do something with it. And let's write all of our case statements. Change model. And finally, we don't have an else. What we have is called a default. So if action.type doesn't match any of these, then just default this. Okay. And what we're going to default to, what are we going to default to in here? If it doesn't match any of those, what are we going to default? It's our else statement, essentially. We want to default our return state, right? So we can just copy it from there. We'll just return state. And we can just copy all of these for their boom. Okay, this is what we're seeing here is these two things are virtually identical, okay? This is just going to make it a lot easier for us to write code and really see what's happening where. We're going to make our code a little more dry by removing this line and all of our else's, things like that, okay? It's easier to understand this one, but you have to also know what case change year even means, right? We're essentially saying if action type equals change year, then do this. If action type equals change model, then do this. If none of these action types match, then do this, right? Whew, all right. That's about, that's about all we got today. We're gonna plug this into React after the break. I would love any questions you have, throw them into Slack. Otherwise, we are going to take a break and come back, and we're going to punch this stuff into React. Well, let's take 5. See you in 5. And yeah. All right, come on back. We're gonna go over one more thing I forgot about, and then we're gonna jump into React. And once we jump into React, it's gonna be like boom, 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 got it. Oh, that was cool. So let's go talk about one more thing. Notice here that I'm calling reducer every time I need to grab an old version of the state or the current version of the state. I need to plug that in. I need to plug the new action in. I need to create a new variable that has the new version of the state. There's got to be an easier way of doing this, right? There is, and it's a new function called dispatch. The dispatch is only going to take the action, and it is going to call the reducer for us. So let's say that dispatch also has, let's just go current state. Dispatch has an idea of what the current state always is. And what it's going to do is it's just going to say current state equals reducer current state action. So what dispatch is going to do for us is it is going to maintain what that current state is, and it is going to take an action, and it's going to call the reducer for us. It's going to pass that current state in, whatever it is, and it's going to give it back to us. Okay. Reducer, where is that at? Reducer. Cool, thank you. All right. Okay, so at this point now, let's take this and let's just say dispatch. We don't have to pass in the state. In fact, let's just make our current state the initial state. And then we are going to go only want our current state. Okay. And then we're going to go to reducer on this one as well with our, and we're going to pass our action in. Okay, so what dispatch is going to do, and let me break this up a little and we can walk through it. So let's just say that somewhere in the ether we have a copy of our current state, whatever that is. What we want to do is we want to call our dispatch. We're going to pass that action in. What is this action? What data type is this action? Does anyone remember what our actions are always? It's always going to be an object, right? So I can actually say type and year payload if I wanted to. Okay, I can actually just throw an object in there as long as it has a type. Then I can throw an object in there, right? We know that actions are always going to have a type property. Okay, so it's going to take that action, and then what it's going to do is it's going to reset what state is to whatever is returned from our reducer. Okay, and is reducer going to be a new object, a new place in memory? Kind of a trick question for you. Is our reducer going to return a new place in memory? You can answer wrong. That's fine. It's yes and no, right? If we just returned the initial state, then no. It's going to say current state equals current state. That's fine. If we do return a new place, then it is going to say current state equals that new place in memory, right? That was a tricky question. So it could be that it stays the same. It could be that it is a new place in memory. Is whatever our current state is pointing to, is that ever going to be mutated? That whatever our current state is pointing to, is that object ever going to be mutated? It will not, okay, because we have made sure of that. And right now, there's nothing holding us to that, but there will be something in the future. And just to make sure, let's make it, all right, current state equals initial state here, all right? Current state equals that initial state, so it's pointing to this place in memory. When we call that first dispatch, it is going to put that initial state and that action in there, so it's going to be that place in memory in the action, and we should hopefully get either a new object or the same object unmutated. You're gonna learn to be like, I don't ever want to hear the term mutated again. Okay, so let's look. Our initial state, make, Chevrolet, model, Corvette, year 2010. Our new state, after dispatch gets called, Chevy, Corvette, 2020, right? Because we did a change year on our first action to 2020. Second, we did a change model, so we get our model of Blazer in 2020, but yet our initial state has never been mutated. Okay, mutate, mutate, mutate. All right. Thankfully for us, we don't have to do any of that. React and later Redux does this part for us. We do have to do this part. All of this part we have to write, okay? But React will do all of that for us. All right. I'm going to save this. Once again, I'm going to give this to you for your notes. We have created some React Redux reducer stuff from scratch. And now let's go plug it in. Let's look at what we have got here. Okay. What we've got is a simple app with a fancy gradient background, and we have a title component. Let's go look inside of our title component, and we'll see that we have some state. We have a title. We have this state that's editing, and it's currently set to false. And we have this state that's new title text, and it's currently set to nothing, right? To an empty string. We're going to check to see if editing is true or false, and if it is, we're going to have a little just currently we're going to have our title in there, but then we are going to have an input if it's, or our title, if it's not editing, it's going to be our title. If it is, we're going to have an input that allows us to change the title text. Okay. So we can, let's do this in the way that we are going to use a reducer for this. Okay. So first and foremost, we are going to add a reducers folder. Reducers. And then in here, we are going to add an index.js. Very, very simple. Okay. What's the first thing we always want to create when we create a reducer? What's the first thing we created before? Our initial state, right? A couple of you and I, Trevor, I'm going to assume that, yeah, you meant initial state, right? Let's create our initial state. We're going to export. And our initial state is going to be an object, okay? So let's go to our title, and let's say, what do we need for our state right now? What is our state currently holding in title? It's holding three things right now, right? We have three pieces of state. We have title, editing, and new title text. We're going to leave new title text on here, and we'll see why in a minute, but we're going to put title and editing on there with these initial states, okay? So let's go title of hello Earthlings. And let's put editing of false. Okay. What is the second thing that we need to create after we create our initial state? Yeah, we need to create the reducer function. Okay, so we're going to say export const. We'll just call it reducer. Yeah, we can call it reducer. Let's call it title reducer so that we don't get confused. Export const. What is our reducer? What two arguments or parameters is our reducer always going to take? State, yes. So state is always going to be first. And then our action. So the order of this absolutely matters. Remember when we wrote our dispatch ourselves, that mattered, right? That's what dispatch is going to call it in the reducer. It's going to put the state in and the action in here. It's going to do the same in React. Okay. For right now, let's just return state. That's all we want to do. I'm going to return state. Okay. Let's go back to our title. And we're going to use a new hook called use reducer. All right. I'm just going to say const. And use reducer is going to look similar to use state, except we are going to get our current state and then our dispatch function, right? And it's pretty similar to use state. We have our current state and our set state function. We're gonna have our current state and our dispatch function. Reducer, we need to plug our stuff in there. So I'm gonna import that. Okay. We're gonna go one up, reducers, and that's it. So in our use reducer here, we can come and look in the React hooks library reference. What we are going to do is we are going to pass it our reducer function and our initial state. Okay, it calls it initial arg. We're not worried about that for right now. We're going to do the reducer and the initial arg. Okay. This is all in our reducer. Oh, look here. It's accurate, stunningly the same as what we've been doing. Not the same exact thing, but. So we're going to pass it our reducer and our initial state. Okay. Use reducer is going to do all of that dispatch and all of that holding the current state and all of this stuff for us. Okay, it's doing all of this for us under the hood. We know how it works, right? We've already written that stuff. We know how it works. So when we come and use it, it's not magic, right? So when I console log state, I should see that initial state. And there we go. And just to show that it is the initial state, there it is. Okay. All right. So in our title here, let us do this. State.title. And then we're going to say state.editing. And we can get rid of both of these things. Whoa, crazy. But notice in here that when I change this initial state, it's going to change it on our page here. Okay, so this is just state for us. We know what state is. We've used it before. This is just state, and it's holding it as a an object. Okay, that's pretty simple right now. I see some typing. I'm going to give it a second. We only have. You can use this with use context, absolutely. And if you combine use context and use reducer, you've essentially made your own Redux, but we won't get there quite yet. Okay, so let's take a look at some of the stuff we need to do here. What are some actions? What are some action types that we should have? Just who wants to name some action stuff for us? I think there should be 2 actions specifically. We need edit, right? We need edit and we need change title. Those are the 2 actions that we really, really, really need. Let's come in here. Let's create our switch. We're going to say action.type. Always you want to type in there. And then we'll just throw our default in. And let's say case is going to be change title. In case change edit. Let's just do change edit for right now. And let's come in here and let's create our action. We can do it in either file. Let's do it in this file just so we can see it up close and personal. I'm going to create an action up here, const edit action. Ooh, this is actually going to be, yeah, that's fine. So what do we need? What key value pairs do we need in this action? So we definitely need a type, right? Do we need a payload? Not every action needs a payload, but let's think about our edit. When we press that edit button, do we need a payload? I don't think we do, right? I don't think we actually need a payload. So we can just say type change edit. Okay, pretty simple. And let's create a click handler. Let's go edit title. And what we're going to do here, when we click on edit title, we just want to dispatch edit action. I didn't have to create a separate edit action up here. I could have just done it right here like this. And if that makes more sense to you, let's leave it there for right now. Okay. So now when we click, well, not quite yet, but when we click on this, we want to say on click, edit title. We're getting there. All right, when I click on this now, what's going to happen? Is it going to change this to an input? We're going to dispatch that action, but let's look. It's actually not going to do anything, right? Why is that? Because our reducer isn't doing anything. All right, so change edit, which let's make sure that's the right one. Yep. doesn't have anything in here. So what do we need to do? We need to return state and then edit true. And now when we click it, editing, there we go. Editing is true. Yeah. We'll get there in a minute. All right, now that we know that that is working, right? That has changed. Oh my gosh. That has changed our state. Our initial state is still the same. It's still there, but it has changed our state. Now we have state editing is true, so we're going to get this input. All right. I'm going to build a little handle change here. This is very simple form. Let's go on change. Okay, all it's doing is updating this current state title. Can we put this stuff in our reducer? Can we put that new title text, whatever's in our input, in the reducer? Yeah, we can. It doesn't really need to be there. And also, like most stuff, we are, this is a pretty contrived example. If we were using a reducer in a bigger app, this reducer would be holding state for many components, right? And we'll see that later on down the line. But this really only belongs to this component. It's just the current state of this little input. So we should get not an error anymore on there. Yep, we don't get an error. And now that updates our state in there, but it doesn't quite update our title yet. So what's the last thing we need to do on here to actually get this to work? We need to create one more action, and we need to plug that into our reducer, right? We need to create this change title action. So before we do that, let's go create the actual action itself. Okay. So what we're going to do is we're going to say const, and we'll say change title. We're going to dispatch an action. Now we do need a payload on this one. Our type should be, we'll call it change title. Remember, our type can be whatever we want to call it. We want a payload on here. And what's our payload going to be? Anyone else have any other ideas what our payload's going to be? Ooh. Well, this change title is actually going to be on this button right here. So it's not going to be e.target.value, and we're already handling the change in the input by right here. All right. So this is going to be that new title text. So now we have a dispatch type, or we have an action type of change title, and a payload of that new title text. Okay, and then let's just add an on click to this button. Call that change title. Is that going to do anything yet? Nope, it's not. Final step. What do we need to return? We need to return a new object with a copy of our current state. What else do we need to return? What should be our next thing that we put in here? What are we trying to change right now? Yeah, we're trying to change our title, right? Remember, our title is in our state. We're trying to change that title. And what are we going to set that title to? Remember, our action is this, right? That's our action. So we have a type of change title and we have a payload of whatever the new title is going to be. Okay. So we're going to say action payload. Now, is that it? Is that all we need? When I press update title, is this going to update the title for us? It will update the title for us. Is it all we need? We're missing one small piece. So let's look at our, give me 2 more minutes. I'm sorry we're running over a little bit. Let's look at our title component here and notice that if the state is not editing, if editing is false, it is going to show us our title. If it is true, it is going to show us our input. So yeah, we need to come in here and we need to change editing to false. Now let's check it out. Update title, and there we go. And we now have it working. Fancy, fancy. This is like way too much code. I'm not gonna lie right now. This is way too much code for changing one little title thing on your app. Like, just for those of you that are like, this is so ridiculous. Why are we writing this much code just to change this one little thing on our app? Agreed. Okay, but this is easy to showcase, you know, that we have 2 pieces of state in our initial state. We're able to you know, capitalize on both of those things, and we're able to change both of those things with one reducer. Okay, so it is too much code for one little thing. If you were ever going to write this title app, do not use a reducer. Like, it's too much. It's ridiculous, but it'll come in handy later on. Okay, would you say the backwards ternary? This is our ternary here. Says if editing is false, then show this, otherwise show this. It is dry. I'd say this is pretty dry. Okay, we would want to have more than one item that calls edit title and calls change title, possibly, but it's pretty dry. I don't see anywhere that we're reusing an absurd amount of code. But that's reducers, okay? Let me you can absolutely say this and switch these 2 things around, right? Yep, you can totally do that. I didn't write this initial code here. Yeah, that works too. Same thing. Ooh, look at that. Boom, boom. All right. Sorry we ran over tonight. I know this is a lot, and please, by all means, I would spend the rest of the night reviewing kind of what's going on here and what we talked about, and then seeing how we, you know, put it into here, and how we utilized it in our app here, and trying to just piece it together and just understand the moving pieces and what goes where and what's affecting what. and really try to understand this pattern. This is a pattern that we were going to be using for quite a while. You also have a couple of weeks coming up to dig in and learn it a little bit more and let it ingrain in your brain a little bit more. I'll have an announcement about some techniques to use over the break. I expect all of you to take a much needed break, but also you don't want to let your brain get stagnant. But that's what's happening with our reducers here. And you can use the use reducer. Honestly, something like 2 things here is not really likely. Kind of want to show you what an actual reducer is going to look like. I think that Replit still has their stuff. This is what a real reducer is going to look like. Okay. I just want to show you when we're talking about using state in a I don't want to do that or that. When we're talking about using state in a production app, this is Replit. They use Redux. This is still a reducer. This is the kind of state they're holding in one reducer right here. All right. Lots and lots and lots of state. Okay. All over the place. Craziness. So this is all one reducer. Just wanted to show you this to show you that it's not this. It is definitely this. All right. But that's what we got for you tonight. Sorry I held you over. Have a great night, everyone. Have an amazing break. I'm going to see you in 2020, and we're going to continue our talk about reducers, and then we're going to jump into Redux, which is amazing, especially now that you know context and you'll know reducers well by then. It's just going to be easy peasy. See you later. Have a good night. See you next year.